Imagine for a second that you are standing at the very edge of a massive, dense forest.
Go.
But as you step inside, you realize pretty quickly this isn't, your typical hiking trail with pines and oaks and the smell of sap.
This sounds a bit like a setting from a sci-fi novel.
It really does. This is what the paper calls a probabilistic
A
forest.
probabilistic forest. I like that.
Stick with me here, because this forest is actually a map of our future. In this forest, every single tree represents a future event.
Okay, so like a big redwood could be.
Oh, that tall redwood over there, that might be the 2024 presidential election. The little sapling growing next to it. That could be the price of Bitcoin next Tuesday.
And the branches on these trees, those are the outcomes.
Those are the possible outcomes, exactly. So you look at the election tree, one branch is candidate A wins, another is candidate B wins.
I'm with you so far.
Now here's where it gets really, really interesting. Imagine that hiding in those branches, I mean literally tucked away in the leaves, is free money.
Yeah.
Just sitting there.
And when you say free money, you don't mean some metaphorical value or, insight. You mean actual dollars.
Cold, hard cash. But there's a catch. To find it, you have to know exactly where the forest is broken. You have to spot where the branches don't quite add up to a whole tree.
So today, we're going hunting.
We are going hunting for that money. We are unpacking a fascinating and frankly a technically dense piece of research titled Unraveling the Probabilistic Forest, Arbitrage in Prediction Markets.
This comes from a team of researchers, Seguillo, Gaffori, Kiffer, and Suarez-Tangel, who decided to take a very close, very mathematical look at the infrastructure of a platform called Polymarket.
And for anyone who hasn't been glued to their screen for the last year, Polymarket is that massive blockchain-based platform where people can bet on, well, pretty much everything.
It's a prediction market.
Okay.
And the core promise of any prediction market is that by aggregating everyone's bets, essentially gathering the world's knowledge and putting a price tag on it, you get a highly accurate probability of a future event.
Right. If the market says there's a 60% chance of rain, you bring an umbrella. It's supposed to be the wisdom of the crowd.
But what this paper shows is that sometimes the market is just wrong. Not wrong about the weather, but wrong about its own internal math.
That's a really key distinction. We aren't talking about trying to predict the future better than the market. We're not saying, oh, I know who will win the Super Bowl and the market is dumb.
No, not at all. We're talking about finding moments where the market literally contradicts itself, where the numbers just don't add up.
Arbitrage.
That's the word.
Arbitrage.
The beautiful, simple art of buying $1 for 90 cents.
Or even less.
And we're going to dive into how these researchers used some seriously sophisticated AI, we're talking large language models like DeepSeek and Mistral, to hunt down these glitches in the matrix.
And the big question we're going to answer.
Yeah.
Did anyone actually find this money? Did anyone exploit these loopholes?
Spoiler alert.
Yes. Oh, yes. To the tune of about $40 million.
$40 million. Just from fixing broken math?
Oh.
That is wild.
It's staggering.
Okay, let's unpack this. We have to start with the landscape. If we're walking into this forest, we need to know the rules of the road. What exactly is Polymarket under the hood?
So fundamentally, Polymarket isn't a casino in the way you might think. It's a platform built on the Polygon blockchain.
Right.
And it operates using something called a central limit order book, or CLB.
A CLB. Sounds like a bad 90s cartoon villain, but that's actually pretty standard finance stuff, isn't it?
It is. It's basically how the New York Stock Exchange works. It's just a list. On one side, you have all the people wanting to buy shares at certain prices. On the other, all the people wanting to sell. The protocol just matches them up.
Okay, so it's a matching engine.
Yeah.
But the mechanism of what you are trading is what really matters here. Right?
Exactly. When you place a bet on Polymarket, you are buying a share in an outcome. Let's say the market question is, will it rain tomorrow? You can buy a yes share or a no share.
And the payout is binary. That's a crucial thing to get your head around. It's not like a stock that can go up 10% or down 15%. Right, it's a binary option. A share always pays out exactly $1 if the outcome happens and $0 if it doesn't. It turns into dust.
Okay.
So the price you see on the screen, let's say it's 60 cents for a yes share, that isn't just a random price. It represents the market's collective probability. If you're willing to pay 60 cents for a potential dollar payout, you are implicitly saying there is a 60% chance of rain.
It's like a lottery ticket, but the price of the ticket changes in real time based on how likely everyone thinks the win is.
That's a great analogy. And because of this structure, there's a golden rule of probability that absolutely must hold true.
The researchers call it exhaustive and mutually exclusive.
Those are some $10 words.
Break that down for us.
Okay, exhaustive means that in any given market, one of the outcomes must happen. One of the branches has to be the right one.
Right. If the question is, will Team A or Team B win, one of them has to win.
Well, or they can tie. So you'd need a third outcome. But yes, all possibilities are covered. That's exhaustive. Then mutually exclusive means that only one outcome can happen.
Team A can't win and lose at the same time.
Unless you're talking about some very strange quantum physics experiment, no.
So mathematically, if you take the price of Team A wins, plus the price of Team B wins, plus the price of the tie.
It has to equal 100%. Or, in financial terms on Polymarket, the price of all those shares combined must equal exactly $1.
Because one of them is guaranteed to pay out $1. If you buy one of every possible outcome, you're holding a winning ticket.
You just don't know which one it is yet. But you know for a fact you will get $1 back. So naturally, the cost to buy that whole bundle should be
$1.
It should be.
But, and this is the but that drives this entire deep dive, sometimes it isn't.
Sometimes the forest breaks. Due to market volatility or panic, or maybe just a lack of liquidity, which just means not enough people are trading, the prices can drift apart.
And that drift creates the arbitrage, the glitch.
Exactly. That's the crack you're looking for.
Okay, let's talk strategies. Let's look at the long strategy first. This is the one that makes the most intuitive sense to me. It's like finding something on the discount aisle.
It's exactly that. Imagine the market is panicking. The price of a yes share drops to 40 cents. And for whatever reason, the price of a no share is also trading at 40 cents.
Okay, so 40 cents plus 40 cents. That's 80 cents total.
Correct. So you can go in, you buy one yes share and one no share. You've now spent a total of 80 cents, and you hold every possible outcome.
So no matter what happens tomorrow, rain, shine, snow, surprise apocalypse, I am walking away with $1.
You are guaranteed to get $1 back from the protocol when the market resolves.
I spent 80 cents, I get $1 back. That is a risk-free 20-cent profit.
That is free money. That is the definition of a free lunch in finance.
I just can't believe these exist. In mature markets, like on Wall Street, high-frequency traders and their algorithms would close those gaps in microseconds. You'd never even see it.
You'd never see it. But in these newer crypto-based prediction markets, the gaps are sitting there, open for seconds, minutes, sometimes even hours.
That's incredible. Okay, so that's buying long. But the paper also talks about a short strategy. Now, how do you short prediction market? You can't just, borrow a share you don't own on the blockchain that easily, can you?
Well, on Polymarket, you sort of can. The mechanism is called minting.
Minting, like printing money.
It's close, because the protocol knows that yes plus no must equal $1. It allows you to do something clever. You can lock up $1 of your own collateral in a smart contract.
Okay.
In exchange for that dollar, the protocol mints. It just creates out of thin air one yes token and one no token, and it gives them both to you.
So I give the machine $1, and it gives me the full set of outcome tokens.
Exactly. You now hold the complete package. Now, imagine the market is going crazy with hype. Overenthusiasm is everywhere. The yes share is trading at 60 cents, and the no share is trading at 50 cents.
Wait, that adds up to $1.10? That shouldn't exist. That's more than $1.
It shouldn't. But if it does, you can do something really smart. You take those two tokens you just minted for a total cost of $1.
Right.
You go to the open market, you sell the yes share for 60 cents, and you sell the no share for 50 cents.
And I've just pocketed $1.10.
But you only spent $1 to mint them in the first place. You've made 10 cents of profit, completely risk-free. You are effectively selling the market's overenthusiasm back to itself.
Okay, so the concept is simple. If the prices don't add up to $1, there's money on the table. But here's the problem. Polymarket isn't just one question. It's thousands and thousands of questions.
It is a massive forest, and checking every single tree for this simple yes-no arbitrage is easy. But checking the connections between all the trees, that's where it gets mathematically explosive.
The paper mentions this computational challenge. If you have thousands of markets comparing every single market to every other single market, the complexity just balloons. They threw a formula at us. O reduce plus M.
Yeah, that's big O notation. It's just a computer science way of saying the problem gets exponentially harder the more things you add.
So it's not feasible for a human.
Think about it. Checking if the price of Bitcoin is related to the price of Ethereum is pretty straightforward. But what about checking if Bitcoin is related to NVIDIA stock, which is related to U.S. interest rates, which in turn is related to the outcome of the 2024 election.
The number of potential connections creates this web so thick you can't possibly navigate it with a simple script.
You can't. You can't just write a simple if-then code. You need something that understands meaning. You need something that knows that Kamala Harris and the vice president are semantically linked, even though the words are completely different.
You need AI.
You need AI. And this is part 2 of our deep dive, the researcher's toolkit. They didn't just write a script to add numbers. They brought in large language models.
And they built a whole pipeline. Let's break down the stack because I think this is fascinating for anyone interested in how this AI stuff actually works in the real world. First up, they used a model called Link Embed Mistral.
Right. Mistral is a very popular, very efficient open source model. They used it specifically for a task called embeddings.
We hear that word embeddings thrown around a lot in AI, but explain it for the listener who isn't a machine learning engineer. What is Mistral actually doing to the market data?
Think of a massive library where all the books are just thrown in a giant pile on the floor. It's chaos. Embeddings are like the Dewey Decimal System for that library.
It's an organization system.
Precisely. The AI reads the text of a market, say, will the Lakers win their basketball game tonight? And it converts that sentence into a vector, which is just a long string of numbers. That string of numbers is like a coordinate that places the market in a huge multidimensional space.
So all the sports markets end up clustered in one corner of the room, and all the crypto markets end up in another.
Exactly. It groups them by topic and meaning. This is a crucial first step because it filters out all the noise.
Yeah.
You don't want to waste your expensive computing power trying to find a logical link between Taylor Swift's new album sales and the price of soybeans.
Right. Keep it in the same ballpark. Don't compare apples to spaceships.
Mistral ensures you aren't doing that.
Okay, so once they have the markets all nicely grouped and categorized, what's the next step? Who actually reads the books?
Then they brought in the heavy hitter for the reasoning part.
Yeah.
DeepSeek R1 Distilled Quinn 32B.
Rolls right off the tongue.
It really does.
So why this specific model? Why not just use something like GPT-4 that everyone's heard of?
It comes down to cost and specialization. They needed a model that could perform these complex logic checks at a massive scale without, bankrupting their research grant. DeepSeek is fine-tuned for these kinds of reasoning steps.
And what did they ask it to do?
They fed pairs of market questions to the LLM and asked it to find semantic dependencies.
Semantic dependencies. So, in plain English, do these two questions actually mean the same thing or rely on each other?
Or does the answer to one logically force the answer to the other? The real goal was to find markets that sound completely different but rely on the exact same underlying logic.
So if I ask, will the sun rise tomorrow? And you ask, will it strictly not be dark tomorrow morning? The AI should know those are dependent.
Exactly. But in prediction markets, it's usually much subtler. So before they unleashed it on the whole data set, they needed to validate if the AI could actually do this reliably. They ran a test.
A calibration.
A calibration, yeah. They showed the LLM single markets where the dependencies are obvious, like Team A wins versus Team A loses.
Did it work? I mean, AI is famous for hallucinating and just making stuff up. Did it actually understand the markets?
For the most part, yes. It correctly identified the logical consistency in about 81.45% of the cases.
81%. That's like a B- in school. It's not an A+ group. What happened in the other 20%?
The usual AI failure modes. Hallucinations and reasoning loops. Sometimes the LLM would get stuck in a circle of logic it couldn't break out of.
Like a computer program in an infinite loop.
Exactly. Or if a market had too many conditions like will Team A win, or Team B, or Team C, or Team D, once you got past 4 or 5 different options, the model started to struggle. It just got overwhelmed.
It couldn't hold all the different branches in its working memory at once. It's just like us.
But 81% is good enough. It's good enough to filter a massive data set down to a manageable kill list of potential targets for the researchers to analyze more closely. It acts as a powerful spotlight in that dark forest.
Okay. So they have their toolkit. They have their AI-generated map of the forest. Now they can start hunting. And what they found, well, let's talk about the different types of arbitrage they actually uncovered, because it's not just one thing, is it?
No, it falls into 2 very distinct categories. The first is what we call type 1, market rebalancing or intramarket arbitrage.
Intramarket. So staying within one single tree, one specific question.
Right. This is the simplest form. Will Bitcoin hit $100,000? Yes or no? As we discussed, if those prices are out of sync, say yes is 40 cents and no is also 40 cents, you go in and you fix it.
This seems like it should be incredibly rare. I mean, surely the bots that are already out there would pick this up instantly.
You would think so,
Hmm.
but the data shows something completely different. The researchers found 7,051 conditions with at least one of these arbitrage opportunities.
7,000. That's not a needle in a haystack. That's a haystack made entirely of needles.
It was pervasive,
Hmm.
and the profit margins they found were shocking. The median profit, and I want to stress the median, not the maximum, was around 60 cents on the dollar in some
Oh,
cases.
60 cents on the dollar.
Right.
So I could spend $1 and be guaranteed to get $1.60 back. That's an insane return.
Now, we have to be a bit careful with that number. That often involves situations with very low liquidity.
Oh, okay.
So you couldn't necessarily dump $1 million into that trade because there just weren't enough shares available to buy or sell.
So it's a high percentage, but a low volume. It's a free lunch, but it's a snack, not a banquet.
For type 1, yes. But then the paper gets really excited about type 2, combinatorial arbitrage.
This is the 3D chess version you were talking about. This is intermarket arbitrage.
This is where you connect two different markets that are logically linked.
And this is where the AI really had to shine.
Exactly. Let's use the U.S. election as an example because the paper uses it a lot. You might have market A, a very simple question. Will the Democrat candidate win the presidency?
Okay, simple enough.
And then you have market B, a much more specific question. Will the Democrat candidate win the presidency by a margin of 1% to 4%?
Okay, I think I see where this is going. Market B is a very specific version of Market A. It's a subset of it.
Precisely. Logic dictates that if the Democrat wins by a margin of 1.4%, then by definition, the Democrat must have won the presidency. It is logically impossible for Market B to resolve to yes and for Market A to resolve to no.
Right, you can't win by 4% and somehow also lose the election. That breaks the laws of physics.
So, mathematically, the price of the general win in Market A should always be higher than or equal to the price of the specific margin win in Market B. The general bucket has to hold more water than the specific little cup.
But sometimes it wasn't.
Sometimes it wasn't. Sometimes the specific niche outcome was trading at a higher probability, a higher price, than the general all-encompassing outcome.
Which is just, it's a logical impossibility. It's like saying it's more likely to rain specifically at 2 p.m. than it is to rain at all today.
That is a perfect analogy, and that is an exploitable logical loop. You can construct a trade where you buy the yes on the cheap general market and bet against the overpriced specific market in a way that guarantees you a profit because of that impossibility.
Did the LLM find a lot of these complex connections?
It analyzed nearly 47,000 pairs of markets. From that, it identified 13 specific dependent pairs, all related to the 2024 U.S. election, that allowed for this kind of complex arbitrage.
Only 13? That does sound much rarer.
It is much rarer. It requires a very specific setup in the markets. They found links between things like the popular vote and the presidency, or a state winner market being linked to a winning margin market.
It's harder to find.
It's harder to find, but it represents a much deeper inefficiency in how people think and bet. They get so focused on the specific bet in front of them, oh, I think he'll win by a landslide, and they completely forget to look at the broader market context.
That's the forest for the trees, literally.
Literally.
Okay, so we have the methods they used, we have the types of traps they found in the forest, and now let's talk numbers. Let's get into the data. Where was money actually hiding?
The study covered a full year, right? From April 2024 to April 2025.
A very eventful year. And the main event of that year was, without a doubt, the 2024 U.S. election.
I'll have to assume that's where all the action was, all the money, all the volume. In terms of sheer volume, yes. Liquidity, the amount of money trading, just spiked massively around November 2024. Everyone and their grandmother was trading on the election. So politics markets accounted for the highest dollar volume of profit simply because that's where the whales were swimming.
But the paper throws a bit of a curveball at us. It wasn't just politics.
So the surprise contender was sports.
Sports. Really?
While politics had the big dollar volume, sports markets had a massive number of individual arbitrage opportunities. And this goes right back to that short strategy we talked about earlier.
Selling the expensive, overhyped tickets.
Exactly. The researchers found that sports markets were very often overvalued. The sum of the probabilities of all the teams winning was often way greater than one.
It's fan optimism. Everyone thinks this is our year.
Irrational fan optimism. You have Chiefs fans betting they'll win. You have 49ers fans betting they'll win. You have Lions fans, God bless them, betting they'll win. Everyone thinks their team is a lock. So the price of yes for every single team gets pushed up.
And if you add them all up,
the total implied probability of someone winning the Super Bowl might be something like 150%. which is impossible. Only one team can win.
So the savvy arbitrager just sits there, mints the full set of tokens for $1, and sells all the overpriced yes shares to all the different fan bases.
And pockets the difference, because they know for a fact that only one of those tickets can possibly pay out. It's basically a tax on fandom.
That is brutal, but effective. The paper also mentioned something they call the crypto anomaly.
Oh yes, the real free money glitch. They found opportunities specifically in crypto-related markets that had the most extreme market discounts.
Why crypto specifically? What's different about it?
2 words: extreme volatility. Crypto markets move so fast, Bitcoin can drop 5% in a matter of minutes. So if a prediction market has a question like, will Solana hit $150 by Friday, and the real-world price suddenly crashes?
So participants on Polymarket might panic or just freeze. The real world moves faster than the bettors can click their mouse.
Exactly. And in those few seconds or minutes, the gap between the yes price and the no price can widen enormously before the market can catch up and realign itself.
It's like the market just completely breaks down for a moment. And in those seconds, the profit per dollar you can make is enormous.
Enormous. We are talking about buying guaranteed dollars for just pennies.
Okay, so we've established the money was there. The map showed where the treasure was buried. The big question is, did anyone actually dig it up? Or is this all just theoretical, paper gains?
Oh, they dug it up. They took it. The researchers analyzed 86 million on-chain bids. This is the beauty of the blockchain. It's all a public record. The tape doesn't lie.
And the final tally, how much was actually extracted?
Approximately $40 million.
Yeah.
To be precise, the paper states $39,587,585.02.
$40 million pulled out of the market just by correcting basic math errors. That is a serious payday.
And what's really interesting is how they took it. The dominant strategy wasn't all that complex 3D chess combinatorial stuff.
No.
The most profitable single strategy was simply buying no.
Buying no. Not buying both, just buying no.
It outperformed just about everything else. It seems it was consistently easier and more profitable to bet against unlikely events than it was to try to short the optimistic ones.
I guess no is often the safer bet in a chaotic world. Being the skeptic pays better than being the dreamer.
In these markets, it seems so. And most of this 40 million came from the simple type 1 arbitrage. The complex combinatorial stuff, the 3D chess we were talking about, it only accounted for about $100,000 of the total profit.
So simple is better. Don't overthink it. Just find the dollar that's selling for 90 cents and buy it.
Precisely. The low-hanging fruit was so abundant that they didn't even need to bother climbing the tree for the complicated stuff.
So who are these people? Are we talking about thousands of little day traders making $5 here and $10 there?
There are some of those for sure, but then there are the whales.
The big fish.
The researchers tracked the activity, and they found that the top user, one single account, made over $2 million in profit purely from these arbitrage strategies.
$2 million. Profit. That's a decent year's work for one person.
And the behavior of that account suggests it wasn't a guy just clicking a mouse. It was high-frequency trading. It was bots. Some of these users placed thousands and thousands of transactions. They are running automated scripts that monitor the forest 247 for these glitches.
There's one specific case study in the paper that just made my jaw drop. The user was at 2.91. We have to talk about what they call the penny trade.
The legend. This case represents a moment of total breakdown in market pricing. At 2.91, found a market likely during a moment of extreme crypto volatility, or maybe a platform glitch, where they were able to buy both the yes token and the no token for less than 2 cents each.
Wait, just let's do that math out loud. 2 cents for the yes share, 2 cents for the no share. That's a total cost of 4 cents for a guaranteed payout of $1.
Essentially, yes. They executed the trade and made a nearly instant profit of over $58,000 on that single trade.
That's not selling dollar bills for 90 cents. That's selling them for nickels. How does that even happen? How can a market break that badly?
It implies a moment where liquidity just completely vanished from the order book, or the algorithms that set the prices just completely, totally hallucinated. It's incredibly rare, but at 2.91 was there with their bot running to catch it.
It sounds almost illegal, like you're stealing.
Well, in a regulated stock market, maybe the trade would be investigated or busted. In the world of crypto, code is law. If the smart contract lets you buy it at that price, it's yours.
It's amazing, but it's not all sunshine and free Ferraris. The paper dedicates a whole section to the challenges and limitations. Because if it was this easy, I'd quit my job right now and start coding.
Right. There are significant technical hurdles that keep the average person out of this game. First, let's go back to the AI. We have to talk about the LLM hallucinations.
We touched on this, but give me a specific example from the paper where the AI got confused.
Ambiguity is the enemy of pure logic. The researchers found the LLM really struggled with subjective or poorly defined terms. For example, there were a lot of markets about tipping point states in the election.
Like, will Pennsylvania be the tipping point state? That's a common election night question.
It's a common political science term. But unless the market creator strictly defines what tipping point means mathematically in the smart contracts resolution source, the AI can't verify the dependency.
It doesn't know if tipping point means the state with the closest margin or the specific state that puts the winning candidate over 270 electoral votes.
And if the AI isn't 100% sure of the logic, it can't execute the arbitrage. It just skips it.
Okay.
Another example was markets about the largest margin. If the question is, will Trump win by the largest margin? The AI immediately asks, against whom? If the opponent isn't specifically named, the logic breaks down.
There was also a really subtle nuance about names. This one is fascinating. Will a Democrat win Montana versus will Kamala Harris flip a Trump state?
This is a great one. To a human, in the context of the 2024 election, Democrat winning the presidency effectively meant Kamala Harris.
Yeah.
We all know she's the candidate.
Right.
But to a strict logic machine, Democrat is a category. Kamala Harris is a specific person.
She could theoretically drop out. She could get sick. Technically, they aren't the exact same logical proposition.
Exactly. So the AI looks at those two markets and says, these are not logically identical, and it skips a potential arbitrage. A human might take that risk, knowing it's 99.99% likely to be the same thing. The AI plays it safe. It is too literal.
So the bots miss out on some opportunities because they lack what we would call common sense.
For now, yes.
And then there's the big blockchain problem, execution risk.
This is the big one. This is what makes it really hard. We talked about buying the yes and the no to hedge your bet. In a perfect world, that would happen atomically.
Meaning both trades happen at the exact same instant or neither of them happens, like pushing one button.
Right. But on an order book system like Polymarket, you often have to buy them as two separate transactions.
Right.
This is called non-atomic arbitrage.
Okay.
So you send your transaction to buy the cheap yes share. By the time that transaction gets processed by the blockchain and you go to buy the no share,
The price has already moved.
someone else might have bought it. Or worse, a more sophisticated bot saw your first trade coming and deliberately jacked up the price of the second one to trap you.
So now I'm stuck holding a yes share I paid for, and I can't hedge it with the cheap no share anymore. You're not arbitrage trading anymore. You're just gambling. You're left holding the bag.
That's called legging risk. You got one leg of the trade in, but you couldn't get the other leg in time.
So you have to be incredibly fast, faster than the block time of the chain itself.
Speed is everything, and you have to account for price slippage. That's why the researchers had to calculate prices using something called VWAP, volume weighted average price, to make their estimates more realistic.
This brings us to the bigger picture. We've talked about the how and the what, but let's talk about the why. Why does all of this matter? In the crypto world, people often talk about MEV, maximal extractable value, and it's often framed as a bad thing, like it's theft from ordinary users.
It's often seen as predatory, yeah. Things like front-running trades, sandwich attacks. It's all about extracting value from other people's transactions. But the researchers argue that in this specific context of prediction markets, these arbitrageurs are actually performing a vital function. They're the immune system of the market.
That's a very charitable way to describe someone taking $40 million out of the system.
But think about it. What is the entire purpose of Polymarket? It's supposed to tell us the truth, or at least the best possible probability, about the future. If the price of yes is 80 cents, we want to be able to believe there's an 80% chance of that thing happening.
Right. It's supposed to be an oracle, a source of truth.
But if the prices are broken, if yes and no add up to 120%, the market is lying to you. It's giving you bad data. It's a broken oracle.
Which makes it completely useless if I'm trying to use Polymarket to actually understand the world or make decisions.
Exactly. The arbitrageurs, the people who are extracting that $40 million, are the ones who are forcing the prices back to reality. By buying the cheap shares, they drive the price up. By selling the expensive ones, they drive the price down. They are the force that compels the math to equal $1 again.
So they're essentially charging a fee for their service, and that fee is their profit to correct the market's accuracy.
They are the editors, making sure the story adds up. Without them, the probabilistic forest would be a complete mess. It would be overgrown with contradictions and unnavigable.
So the researchers view these markets as a forest that needs constant pruning.
And currently that forest is messy. It's inefficient. The fact that there was $40 million of free money just lying on the ground for the taking suggests the market isn't fully mature yet.
But as tools like these LLMs get better and more accessible,
As the AI agents become more sophisticated and more autonomous, that free money is going to become much, much harder to find. The agents will compete against each other to close those gaps in milliseconds, not minutes. The forest will become perfectly manicured.
which brings us to a kind of a crazy thought. We started this deep dive by imagining a human observer walking through this forest. But in the future, are humans even allowed in the forest?
That is the real multi-million-dollar question, isn't it? Right now, human intuition still plays a role. We can understand the nuance of tipping point or that Kamala equals Democrat better than the bot can. We can spot things the AI misses.
But that gap is closing fast.
It's closing very fast. And remember, the researchers here used off-the-shelf models. They used Mistral. They used DeepSeek. They didn't have to build Skynet from scratch. They used tools that pretty much anyone can download and start experimenting with.
And those tools are getting exponentially better every 6 months.
So to summarize, we've explored how Polymarket's probabilities can break. We've seen how AI can be used as a high-powered flashlight to find the cracks in the system. And we've seen that savvy traders and their bots have extracted a fortune by basically acting as the market's spell checker.
It's a fascinating ecosystem. It's finance, it's computer science, and it's human psychology all wrapped up into one chaotic, beautiful system.
I think so.
Here's a final thought to leave you with. If prediction markets really are the future of truth, the place we all go to find out what's really going to happen bypassing the pundits and the media noise, then these arbitrageurs are the guardians of that truth.
The keepers of the oracle.
But if the people keeping the oracle honest are increasingly AI agents, and the entities trading on the oracle's information are also AI agents, eventually the market just becomes AI talking to AI.
It becomes a completely closed loop, a conversation we're not a part of.
Will human intuition or even human profit have any place left in the prediction market of the future? Or will we just be standing outside the perfectly manicured forest, waiting for the machines to print out a little slip of paper telling us who won the election?
That is a thought worth mulling over. Are we building these systems to be gardeners, or are we just going to end up as tourists?
Huge thanks to Seguio, Ghaffori, Kiffer, and Suarez Tangil for this incredible paper and for giving us the map to this forest. And thanks to you, the learner, for diving into the math of the future with us.
Keep questioning the probabilities.
We'll see you in the next deep dive.